Hello. Now this was the homework problem that I told you to solve in the previous class. So let us see the solution now. Now in this class we have to basically see the first of all the principal angles, means the location of the principal planes, right? And on those principal planes we have to find the principal stresses. Okay, so let us begin one by one. So first of all we will find the location of principal planes, and we find the location of principal planes by finding the principal angles. Okay, so we know the formula from a previous class. If you remember, tangent of 2 theta principal is tau xy, which is the shear stress on this, divided by sigma x minus sigma y divided by 2, and sigma x and sigma y are these normal stresses. Okay, so let us find the values of these sigma x. Okay, let us say this is x, positive x axis, and this is positive y axis. So based on this, so we got sigma x is positive, right, because they are in the same direction, right? So sigma x is plus 20 megapascal, and we have sigma y. Now sigma y is opposite, right? So it is negative, so it is minus 10 megapascal, and we have tau xy, which is the shear stress. So we can find the shear stress sign using both these arrows. So this and this, they are in the same direction, which means it is positive. Or we can also find the sign of shear stress using this arrow. Again, they are in the same direction. Okay, so it means shear stress is positive 35. Okay, 35 megapascal. Okay, so now we know, and we are good to find the theta p now. Okay, so tau xy is 35 whole divided by 20 minus 10 divided by 2. Okay, so let me feed this formula in the calculator, and I will get the value of theta p. Okay, so let me use the calculator. 2 times I will denote theta p on calculator using x. So tan 2x is equals 35 whole divided by 20 minus 10 divided by 2. Okay, so we got two angles, 33.4 degrees, and the other angle is 123.4 degrees. Okay, so from here these angles you will understand 33.4 and 123.4 is the correct option. Okay, because others does not have these angles. Okay, so we already know, and I had already told you in the previous class that option B is the correct. Okay, and by the way, there was a small typo in the in the previous class. I have shown here 44, I think, and here I show minus 35, and I made the correction. Okay, and I apologize for that typo. Okay, now since we know the principal planes, location of principal planes, we know the theta p. So let us find the principal stress on this plane, and then we will find the the principal stress on this plane. Okay, then we will compare both the stresses and see which one is the maximum and which one is the minimum. The maximum is the major principal principal stress, and the minimum is the minor principal stress. Okay, so again I told you we can use the direct formula like this. Okay, sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, but the problem here is we will find the principal stresses. Okay, but we don't know which which one belongs to which. Okay, I mean which stress is on which principal plane. Okay, so instead of using this formula we will use the basic formula. Okay, because that will help us to identify the plane on which that stress is acting. Okay, so we will use sigma x prime is sigma x plus sigma y divided by 2 plus sigma x minus sigma y whole divided by 2 cosine of 2 theta plus tau xy sine of 2 theta. Okay, now we are going to use the values of theta p. Okay, So when we use the value of, when we use theta p instead of theta, so this becomes what? It becomes principal stress, right? Because we are using the principal, you know, the principal angle, right? So the stress which we get here, the normal stress, will automatically be the principal stress, because the definition of principal stress is the sigma x prime, or the normal stress on principal planes. Okay, so first I will find at this, at theta p equals 33.4 degrees. Okay, now here the sigma principal is going to be, so let me use a calculator to find the value. It is sigma x plus sigma y by 2, 20 plus minus 10 divided by 2, plus sigma x minus sigma y by 2, so it is 20 minus minus 10 by 2, times cosine of 2 times of 33.4, then plus tau xy, which is 35, times sine of 2 times of 33.4. okay, so we got 43 here, 43.08 approximately, okay, megapascal. Okay, so which matches with, you know, this stress. Okay, and at theta p equals 123.4 degrees, we got sigma p to be, and by the way, here we should get minus 33. Okay, so I have already typed the values on my calculator. I just need to change the angle. Okay, so it is now the angle is 123.4, right? This angle, right? 123.4, also in the cosine term, 123.4. so I got negative 33.08 approximately megapascal. Okay, so which aligns with this. So we already know option B is the correct, right? Now what is important right now is to identify which one is the, you know, major principal stress and which one is the minor. Okay, so as I told you, the maximum stress is the major. So as you can see here, 43 and 33, 43 is maximum, so this one is the major principal stress, and we denote a major principal stress with sigma p1. Okay, and this becomes major principal plane, so it is theta p1. Okay, so this becomes minor principal stress sigma p2, and this becomes minor principal plane theta p2. Okay, now other part of the question is draw the state of stress on the principal plane. Okay, so let us draw it here. Let me change the color first. So let us say this is the, you know, before rotation. Now after rotation, now we have to rotate it by 33.4 degrees, right? 33.4 degrees. Okay, so because 33.4 degrees is positive, and we know in the plane stress transformation an anti-clockwise angle. Okay, so this is you know, default, you know, without rotation. So I have to move in the anti-clockwise. Why? Because 33.4 is positive, and positive means anti-clockwise rotation. Okay, so this thing is 33.4 degrees, right? And it automatically means this plane is 123.4 degrees. Okay, so let me draw the body now. So we will draw here. Okay, now let us draw the stresses. Okay, now at 33.4 degree plane, we have this sigma p1, which is positive. Okay, so this one, it is 43.08 megapascal, right? Now at this plane, which is 123, right, as you can see, we have negative 33. Okay, so negative means, you know, compression. Okay, so this one is negative 33.08 megapascal. Okay, so you can see this is towards and this is away. Okay, so now if you wish, you can draw the, you know, complementary stresses. This one is the complementary stress of this one. Okay, so 33.08 megapascal, and this one is the complementary stress of this, okay, 43.08 megapascal. Okay, so we have also our sketch is ready, and it shows the principal stresses and the principal planes. Okay, so I hope you understand everything. Okay, now if you have any doubt, you can comment or you can contact me. So see you in the next class. Thank you.